So hi guys, like today I'm going to discuss about real-time language translations with Nvidia NIM, and also we are going to implement this with AWS Amplify and EC2 instance in AWS. Yeah. Hi, my name is Aditya and I'm working as an AI developer at Camu, and I'm having around 4 plus years of experience related to AI, ML, blockchain, DevOps, and almost all the related fields related to backend, front end, and almost all the development stuffs. So I'm a Gen AI enthusiast, and I'm working on almost all the things related to AI, and I'm also doing some open source contributions. So other than that, I have two patents which is funded by Government of India, Department of Science and Technologies. So that's a short intro about me. So let's discuss what is NIM. So Nvidia NIM, it's an Nvidia inference microservices. So microservices, it's like we'll be having different services which are shortly split, and like we'll be having services like running separately. Like it's an containerized stuff, and it is in cloud native microservices. So it will be running everything separately. So we can integrate almost every stuff. And the major advantage of NIM here, what we are going to discuss, it increases the speed of our deployment and of the environment that which you are going to use to more than almost 50 to 90%. So that's the speed that which you will be actually seeing that. And other than that, it is built with they are giving almost all the pre-built containers, and also other than that, they are also giving us standard APIs. They are also supporting custom models. We can also deploy our own LLMs in that. So other than that, we can also train it with domain specific to our own domain. We can make it generic, and we can make it our own domain specific. And also it is optimized for engine performance. It is having different layers of performance, and like there are many advantages. Like when we go with NIM, it is actually enterprise level architecture. So it is having monitoring stuffs. It is also having everything that an enterprise actually needs. So that's what Nvidia NIM is all about, and why we need to go to NIM. Okay, so there are many other use cases other than NIM. Like we are having Olama, where we can deploy our LLM models in our local servers itself, or in our local system itself. So what makes Nvidia NIM more special? It's that when we deploy that Nvidia NIM, we can deploy it anywhere in our own data centers, in our own workspace, in local systems, in AWS servers, or anywhere where we have the compatible stuff that is actually needed. So if our system is if our system is compatible, we can directly deploy it anywhere. So that's one of the biggest advantage. And other thing is, it's the APIs that which they have built is it's in industrial standards. So it's actually an greater advantage. So other than that is, we can also build it with domain specific models. So based on a domain, if you are going to look at if there is a use case for software technologies, if there is a use case for logistics, if there is a use case for anything related to any other stuffs, so we can actually make them more generic to the domain specific. And we can also integrate like multiple LLM models and bring everything together and make use of that, like integrating all the other microservices together to build an UA platform, something like that. So it's the same way. What we can do is, we can bring all the microservices but with LLMs. So that's what we are going to discuss here. So it's actually an enterprise grade API AI models. Okay. So other than that, what we are seeing here is the architecture. So the industrial architecture, what they are doing here is, they are supporting TensorRT and all the CNNs, and Triton inference servers, cloud native stacks, and customizable cache. So these are the stuffs that they are actually having. That other than this is, they are having containerization stuffs like Kubernetes and Docker. And in the base level, what we actually need is NVIDIA CUDA, which is the driver. With that only, we'll be connecting with the GPU. So yeah. So what are the prerequisites for this? So the first stuff, we actually need is NVIDIA AI Enterprise license, which is the main thing. They are actually providing 90 days trial. So with that, what we'll be getting is, we'll be getting the access to the NIM. You can actually try it out with that. And without Nvidia AI enterprise license, you can also try it out with developer license. So they are also providing for developers, but it's actually limited. But enterprise level license, they are giving you almost all the access to that. So Nvidia is having almost everything related to AI, and like you can actually explore that. And other than that, the main stuff what we needed is GPU. At least we need a Tesla T4 or X large in the AWS EC2. So other than that is we need to do the setup of Dockers and other basic stuffs like Python, and almost some other like driver stuffs. We need to install a CUDA drivers. When we do NVIDIA-SMI, we'll be getting this. If the drivers is actually set up, we'll be looking on how much the graphical processing unit actually uses. So that's the thing. So other than that, the use case that which we are going to discuss is related to like real-time language translation. So if you are going to translate a language like from a single language to another language, like we are having multiple models for that. So but what model we are going to use is here is Megatron 1B NMT. So it is built by Nvidia itself, and it is actually having 1.5 billion like parameters, and it is actually supporting 33 different languages. Like you can select from one languages to other languages. So this is a simple use case where we can actually test it out in the UI itself. But what we are going to do is we are going to deploy it in AWS EC2, and also what we are going to do is we'll be having an interactive UI for that, where we can actually use the same API, same model, but in a local system, not with the API that Nvidia actually provides. So when we actually do this, we need a Tesla T4 or anything higher above than that. And I'm actually having 16 GB of RAM and 16 GB of GPU, which is actually more sufficient. And with this, what we can do is we can actually record in real time. We can actually translate in real time, which is very faster. So when we go with other LLM models, when we give an input text, and we'll be waiting for the output text, it takes around 5 to 10 seconds or more to generate a translation of from one language to other language. So but Nvidia NIM, it's actually giving that in real time, which is very faster than many other stuffs that's currently available in the market. So what happens is if you are having multiple use cases, like if you are having a use case like customer services, they will be asking us any questions in any other languages. We can actually translate to the language that which the user is convenient with, and we can also ask the model to do a RAG, and we can also get the data from there, and we can actually use that. So that will be again translating it back to the user's preferred language, so which will be the microservices, right? So we will be connecting different levels of microservices together, and with this it will be giving the assistant will be giving us in multilingual, and it will be more faster. We can also integrate with the other model that Nvidia provides, so which is they are actually providing for voice assistance also they are providing, so you can actually use that. So what happens here is you see this, yeah, so they are having almost 33 different languages. You can select this language, and all you need to do is just run this, and it will be giving you in real time. So this is done with the API, but what we are going to do is we are going to do it with Docker. So yeah, that's the use case. So let's directly move into the demo part, and yeah, just a minute. So yeah, first step what you need to do is you need to run the Docker login nvcr.io. With this, it will be prompting you the username, and with the username you need to give this as input. After giving this as input, you need to paste the API. So to get that API, you can click on the build this with name, and you can select the self-hosted API, and you can just click on the generate API. It will be giving you the API, and you can copy that, you can paste it out. Okay, so you can paste it out here, and other than that you need to export the same API with this name ngc API key. So other than that, this currently what we are going to use is Megatron 1B NMT model. So I have already run this over here and it's currently running in, so it will take almost 30 to 40 minutes based on the network speed. So once that's running, it will be downloading almost 3 to 4 models. Yeah, it's here. So it's drawing Megatron MT any to any 1B model, and it's doing the classifier, decoder, and encoders. So it's actually downloading all the models, and it will be running in different layers. So once it's running in different layers, we can actually what NIM does is it's actually running the, for example, let's take Megatron any to any, it 1B model, it will be running in first layer, and the classifier will be in the second, decoder will be in the third, and encoder will be in the fourth. So what happens is if we give the target languages, it can actually decode, it can actually use the decoder and encoder directly. If we are not giving the specific languages, what it will do is it will do the classifier. So it will classify what language that which you are giving as input, and what is the expected language. Actually we need to give the expected language. So when we give that, it actually understands what language that which are giving as input, and it will be automatically generating the output in the specific language that which you are giving. So that's how the layers actually works, and it's working in real time. So I have the React code as well. So other than that, let's take a look on this part. So to get the Riva setup, you need to run this ngc registry resource download. Once you run this, you will be getting the Riva setup, which is where you will be getting almost all the speech related and audio related stuffs. That's where you will be running, and when you run that, you will be having Riva init, Riva start. So with this, this is where you need to start before you run the server, for which before you run the Docker container. So once you run this, it will be getting all the speech related models, and everything will be downloaded in your local system. So once that's downloaded, you can directly run the second command, which is docker run -it, and this will actually run in your specific port. I have changed it to 3003 port. And the other thing is I'm exporting the container name over here. This is they both are the same commands. Okay, so this is in single line, this is in more elaborate way. Okay, so when I actually run it over here, and you can see that it started, and the UI it's also started over here. So for the UI, we are also actually having the code for that, which Nvidia is actually providing in the Python clients, and they are having for automatic speech recognition, which is ASR, NLP, and T2S, text to speech. And like in the ASR, what we are having is we are having the transcriber file offline and mic. It will be streaming the audio. It will be automatically doing this stuff, so you can actually play around with this. So currently what we'll be doing is we'll be transcribing. So that's transcribing is nothing but it's like translating from one language to other language. So I have the UI over here, and it's actually running like the server that which I'm using is Tesla T4 X large in AWS EC2. And here we are having almost around 30 languages. Like I have added only few languages here. And for the React code, what I have done is I have been using AWS Amplify and the app.js pages here. Okay, so here I have actually added only around 10 languages over here. Like there are multiple other languages as well. You can actually see it in this page, in the home page, in the model card. You can see what are the languages that they are actually supporting. They are actually supporting more than 33 languages, namely as here. Okay, so I have added this here, and we can select whatever the languages which you want, like this. Hi, how are you? Like when I click on the translate, it will just go and hit the API. We can see that over here it's actually translating and it's generating the content like this. So what happens is you can see this here. You can also select multiple languages like this, and it will be giving the output in real time. It's much faster, right? So what we can do is we can also We can also add other stuffs like translate this to voice, and you can add another one button. Like I'll do that in our next demo. So what we can do is we can add a voice button, and when we click on that, it will be speaking whatever the content that's here in the real time also. So it will be much faster than any other models that which are going to run in locally. So like we can also test it out with bigger text. Like we'll copy this itself. Yeah, we can copy this and test it out. We can see how much faster it's actually generating. So it's taking around 2 to 3 seconds, I guess. Let's see the back. It's taking around 5 seconds for this to complete. But it's somewhat larger text, right, around 50 plus words. So yeah, it's actually doing a pretty good work, but it's doing this in real time. You can also stream this content with WebSockets. We can connect that with the React UI, and it will be giving. We can also stream the content. So why it's delaying is because like I am not streaming the content in the backend, so there is a delay in that because of that. So when you stream that content, you can see that real time, seeing almost all the words, word by word contents like that. So other than that, let's move on to the next slide, which is here. And what are the benefits of using the Nvidia NIM? So we already know the performance. It's doing the higher speed inference capabilities, and also it is an enterprise grade. We can also scale it actually. So other than that, it's we are having the REST APIs. We can also deploy in almost any other clouds like AWS cloud. We can also deploy it in GCP, Azure, or also in your own data center. So that's what integration comes in. Other than in management, you can also isolate the management, and also we can also have almost everything related to the environment. Other than that, we can also have easy monitoring. So everything else related to isolation, and it will be like all our data that which you are going to run, it will be within our service. So wherever you are going to run, it's going to be within our service, and it's going to be easy for monitoring, and it's also going to be easily scalable if you are going to run it in our local servers. In AWS servers, we can also easily scale it like based on the user servers, user access. We can also scale it. So yeah, also the security stuff that which Nvidia NIM provides, it's highly configurable, and also you can I can control the access also. Like they are providing, if you are going to use the Nvidia's cloud platform itself, they are providing like role based access controls also. So based on the role, you can also give them access. Like you can also control them, restricting their access. Like you can also control if the user cannot run more than this amount of time or more than this amount of APIs. We can actually control that in the Nvidia NIM itself. Other than that, you can also do it in our locals, in our server itself. So that's the security part. Other than that, it's actually cost effective. Like when you're going to run it in your own servers, it's based on the server cost that which you're going to use. Other than that, when you're going to run it in your when you're going to use the Nvidia cloud, it's actually based on the server usage. Like it's actually serverless, based on the user capabilities, based on how much the user uses, you need to pay according to that. So that these are the benefits. And other than that, it's actually 95% more speed, and it makes the deployment more faster. It makes it more easy to deploy. So which is what I found it here. And it actually takes almost 30 minutes to actually deploy in the Docker container itself. So once that's done, you can actually test it out anytime, right? So you can detach the Docker, and it will be running the backend anytime. You can get the responses very faster. So that's what I see, very great stuffs in this. So in our next video, what we'll be discussing is we'll be trying to integrate two different Nvidia NIMs together, and we will also try to do our own custom model. We will try to do a custom model in Nvidia NIM. So with that, what we can do is we can actually bring up multiple microservices together, and we can also test it out, giving one's output to the other microservices, and we can actually use it in multiple different ways. It's based on our own ideas. Like the that's the greatest potential that Nvidia NIM actually provides. So other than that, yeah, so this is my profile, and you can actually see, follow me in LinkedIn and GitHub. So this is where I'll be posting the code that which I've done, the instructions and everything. So you can follow me in LinkedIn. Yeah, thank you. Let's see.